students, in the last lecture we learned about three-dimensional viewing pipelining. In this lecture we will learn about 3D viewing parameters. In the 3D viewing parameters we will learn about how modeling coordinates will be converted on the device coordinates. Means that in the three-dimensional images how it will be become as a 2D devices. So how, which parameters we are using in the viewing pipelining, these all the things we will learn in the viewing parameter. Okay, so suppose that, okay, first I will tell you abstract idea about the three-dimensional viewing pipelining so that you can understand very well about the 3D viewing parameter. So here you can see all the steps we will see in the viewing pipelining. First will MC means modeling coordinate. After modeling coordinates it will be become as the modeling transformation. Modeling transformation it will become on the word coordinates. After word coordinates that will become as a viewing transformation. After viewing transformation, viewing coordinates are there. Transformations, projection coordinates, then viewport, after that device coordinates. So here you can see first one is word coordinates, then view coordinates, then projection coordinates, then device coordinates. So now if you are talking about the coordinates, that means you have to talk about the axis or coordinate system, right? So here first word coordinate systems are there. XW means word coordinate system, x-axis, word coordinate system, y-axis, word coordinate system, z-axis. Okay, here this is three-dimensional object where L point is called the look at point or view reference point. Means that in this point your device has to be focus. Okay, then again another one viewport xv yv, means that xv yv and zv, means that in the viewport coordinates are x direction, y direction and z direction, and last coordinates are there x, y and z are the device coordinates. Okay, so these are the three coordinates are there: word coordinates, view coordinates and device coordinates. Okay, so here how this will work viewing pipelining, now you have to try to understand. Okay, so here first the device coordinates will see. Device coordinates you can suppose that one camera is there. So one camera is here, the camera will see that object and this is the focus area L. Okay, so when that image will be showing here, that means these 3D images will become in the 2D image. Okay, this is the 2D, but in the camera have capability to show 3D. How it will be 3D means first X horizontal, Y vertical and Z is the depth. You can see now in the camera when you have to take the images, then you can understand about the depth of the images also, right? So this depth is showing the Z axis. Okay, so here xy is the device coordinates, this xv, yv, zv are the view coordinates, and xw, yw and zw are the word coordinates. So now you can see here first is modeling coordinates, modeling transformation. After modeling transformation wc is coming. Wc means word coordinates. So here we already have this object word coordinate system. Okay, after word coordinate system we have to do viewing transformation. In the viewing transformation there is one vector is going from the look at point. One vector is going from look at point to the viewport. Okay, so that vector is called the n, that will be perpendicular from the view plane. Okay, that will be the perpendicular from the view plane, or view plane means that will be xy plane. View plane xy plane, how it will become? Because view plane is the device coordinates and device have two dimensions x and y. So whatever three dimensional things are coming, that will be projected in the two dimensional plane. So this xyz image will be going in the two-dimension xy plane. So that n vector is perpendicular the view plane, and view plane is the x and y. So xy perpendicular to the n. Get it? Now next is n will be perpendicular to the view plane. So it means in the view plane have n vector which will be perpendicular on the xy plane. Now we are coming to the device coordinates. In the device coordinates have their own coordinates are there. What do you mean by the here device? You can see here in the big object. Okay, so here this is the device coordinates. Device, okay, device have one vector in the up vector, okay, view up vector, which will be denoted as v, and that v is parallel to the x plane, okay, and view view up vector is denoted as v, okay, and v is the perpendicular on the x or parallel to the y axis, okay. So here up vector is v, that will be parallel to the y axis and perpendicular to the x axis. So if we have n vector, that will be perpendicular to the xy plane. If we have up vector, that will be shown as v and parallel to the y. That means we can find out the another vector is u, that will be parallel with the x-axis. So device coordinates also have three vectors are there. First is u parallel to the x-axis, v parallel to the y-axis, and n parallel to the z-axis or perpendicular from the view plane or xy. After this all coordinates we have to find out, then we can transform image from 3D to 2D, so that from the modeling coordinates, from the word coordinates, we can get device coordinates easily. I hope you understand about the viewing parameters. Thank you.